All right, guys, so we're going to discuss section 11.1. The title of this lesson is Sequence and Series, and this is an introduction to sequence and series. And if I'm not mistaken, that is going to be the topics a little bit more in depth that we will review in 11.2 and 11.3. So, what is a sequence? So, if I were to put this in layman's terms and not a technical definition, I would say that a sequence is a pattern. When we're discussing sequences, we have terms in that sequence. And when we look at those terms, we will see an obvious pattern typically. Sometimes it might take us a little bit of work to determine what that pattern is and how we get from point A to point B. But there it is a pattern. So we have some vocabulary terms here that we use to describe different types of sequences. So we have a finite sequence. Let's see if I can highlight this for us. So we have what we refer to, that's dark, as a finite sequence. And for me, in layman's terms, again, I would describe that as a pattern that ends, that stops. It has a particular number of terms in that sequence and it ends. Whereas that infinite sequence, that is going to go on forever. There's a pattern there, but there's no end to that pattern. It just continues on forever. Okay, and again, I kind of hit on that last definition there where it talks about the terms of a sequence. So the terms of a sequence are denoted by the letter A with a subscript representing the term number. So we talk about A sub 1, that is the first term in our sequence. A sub 2, that is the second term in our sequence. Is A sub 3, and so on. So those subscripts tell us the order and the placement of that particular term. So bringing all of this together, we want to look at problem 1. It says, write the first 4 terms of the sequence defined by the nth term. So we're just going to look at this. And before I jump on this, I would like for us to look over here. I have my sequence and I have a function here. So what we are looking at is this first graph. So we are going to substitute, if I may say that, substitute into this function or this sequence, but we are only going to substitute whole numbers here. So what we're going to do, and let me just jump in and get started. We're going to say that our first term in this sequence can be found by substituting 1 into the place of n. So 1 squared plus 5 gives me 1 plus 5, which is 6. And if you look at my graph, I have 1 and 6 on that graph. So we're going to continue this pattern or this sequence. So to find the second term in this pattern, we would take 2 and substitute 2 into that sequence. That would give me 4 plus 5, which gives me 9. And if it says write the first 4 terms. So what we are looking to do is find A sub 3 and A sub 4. And we're going to substitute those values in again into this sequence. So that would give me 9 plus 5, which gives me 14. And then down here, this gives me 4 squared plus 5, which gives me 16 plus 5, which is 21. Now, guys, if I'm going too fast, you guys remember you can always pause this video and rewind. But essentially, what we did here is we just took these numbers and we substituted them into